chemical bonding, please. Take that, please. Chemical bonding. Chemical bonding is a lasting attraction. Chemical bonding is a lasting attraction between atoms. Lasting attraction between atoms, ions or molecules. A lasting attraction between atoms, ions or molecules that enables the formation of chemical compound. That enables the formation of chemical compounds. Full stop. Atoms of elements tend to combine. Atoms of elements tend to combine together in order to become stable. Atoms of elements tend to combine together in order to become stable. This combination to form a compound, affects their individual electronic configuration. Individual electron or electronic configuration. Individual electronic configuration. How the electrons, how these electron configuration change, when atoms are combined, how these electron configuration changes when electrons, or when atoms, when atoms are combined, forms the basis of chemical bonding. Forms the basis of chemical bonding. So many things. Types of chemical bonding. Types of chemical bonding. There are two main types. There are two main types of chemical bonding. Two main types of chemical bonding, which includes, first one is called electrovalent, also known as ionic bonding. The second one there is covalent bonding. Under covalent, there are two types. One is ordinary covalent. The other one is what? So there's two types of covalent bonding. There's the ordinary covalent, there's a coordinate covalent bonding. Let's discuss these ones. Let's discuss this one next. Number one. Electrovalent bonding. Electrovalent bonding, also called ionic bonding, involves the transfer of electrons. Also called ionic bonding, involves the transfer of electrons from one atom to another involves the transfer of electrons from one atom to another. Involves the transfer of electrons from one atom to another. Full stop. The transfer and acceptance creates ionic. The transfer and acceptance creates ionic or charged particles. Creates ionic or charged particles which are attracted to each other. Creates ionic or charged particles which are attracted to each other. Full stop. Let's discuss that a bit. When it comes to defining electrovalent, the most important term there is what? Transfer. That's the most important term there. Transfer of what? Of electron. Between what? Between reacting atoms. Now we just said the transfer, also called donation and acceptance of electrons, creates ionic species. Question is this: if an atom is transferring an electron, what kind of ionic species is formed? Is it a positive or a negative? One is transferring. An atom is transferring electrons. What kind of atom is formed? Is it a positively charged ionic species or a negatively charged ionic species? Which of them? Positively charged, right? If it's accepted because of that, it's negatively charged. So don't forget, we said this before too, that atoms donate electrons become what they're positively charged, and then don't do what in there, accept electrons become what? Negatively charged. All right. Example. Consider the kind of bond. Example. Consider the kind of bonding that occurs in NaCl, sodium chloride. NaCl. Example. Consider the kind of bonding that occurs in NaCl, that's sodium chloride. Sodium chloride, NaCl. Consider the kind of bonding that occurs in sodium chloride, NaCl. Alright, so look at it. We use diagram to illustrate this thing. So first of all, identify the elements here. I have sodium, Na. Atomic number what there? 11. Sodium. Next I have chlorine, Cl. Atomic number what there? 17. So the first concept now need to draw their electronic configuration. For sodium, Na having atomic number 11. Let's use KLMN shell. It will be, draw your K shell first, 2 electrons, 1, 2. Draw your L shell. Of course, L maximum, as we said, is 8. Becomes 1, 2, 3, 4, 5, 6, 7, 8. In total, I've placed 10 electrons here. 1 more is left, since I have 11 electrons. So 1 more is left. That becomes this. Okay? So that's my sodium atom. For chlorine, atomic number 17. Draw the KLMN shell. I have chlorine as, first of all, K shell, 1, 2. Draw L shell, 8 maximum, 1, 2, 3, 4, 5, 6, 7, 8. I now have 10 here. So 17 minus 10, I still have 7 more to go. So I'll pick the third shell and place 7 more electrons. 1, 2, 3, 4, 5, 6, and what point there? And 7. Alright. So when these two combine, what happens? If I have sodium, Na combined with chlorine, Cl. Look at this. Look at this. I'm having sodium as this. So this as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 2, 8, and then 1 here. So level to that. This one is now combining with chlorine. Chlorine we said is 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, and then 7. That becomes 1, 2, 3, 4, 5, 6, and then 7. So I have these. So at this point now, these two atoms are combined to form the table salt NaCl. Question: are any of these two atoms stable? No. Why? Because we said when it comes to stability of an atom, it depends on two conditions. An atom is said to be stable if it has what there? Either octet or what there? Duplet configuration. By octet configuration, we mean the number of electrons on the outermost shell must be 8. That's octet. By duplet configuration, we mean that what there? The total number of electrons on the outermost shell must be what there? 2. If I look at this one here, here's my outermost shell. How many electrons here? It's 1. So it's not duplet, it's not octet. If I look at this one here, I have 7 valence electrons. It's not duplet, it's not octet. That means neither of these are stable. Right, so how do I combine them such that they become stable? What will happen is this. So sodium here will have to transfer this electron to this point here. Right. If this electron from sodium comes here, let me call this perhaps, let me call it an X. Yeah? X meaning X is now the transferred electrons. So if this one now comes here, what do you now have? You observe that for sodium now, I'll not be having this one as 1, 2, this one here, 1, 2, 3, 4, 5, 6, 7, 8. Observe that this last one here will be no electron there because it has moved. So here because of the empty. I'm now left with just 2 8. Combining with for chlorine, I now have 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. This one here. 1, 2, 3, 4, 5, 6, 7, and then you borrowed electron that becomes 8. So observe here now. So that now become what there? 8 electrons or 8 valence electrons. That's now octet configuration. It's now stable. This one here now has now become what there? 8 again. 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. That becomes stable. It's now the concept of electrovalent combination. Transfer electrons until both atoms become what there? Stable. That's it. Check out please. Other examples of electrovalent bonding occurs in compounds. Other examples of electrovalent bonding occurs in compounds such as you have this, you have this, you have this, this. Right, so these are compounds where electrovalent bonding also occurs. What do you call this? Magnesium chloride. What do you call this? What do you call this? What's the oxidation number of magnesium here? What's the oxidation number of magnesium here? How many? +2. What's the oxidation number of aluminium here? We did this stuff in the previous class. Oxidation number concept. Okay. Hope you can draw these things. That's the draw. Well, it's jamb, so that's the draw. But hope you can draw this stuff. You know it works.
Yes.
Huh? Draw this stuff. Magnesium, chlorine. Okay. Let me just leave it there. It's not a wine class, it's jamb class. So yeah. Look at here. If it affects anything, yes, it does. What does this mean? It means you have on there one magnesium atom and what there? 2 chlorine atom. Alright, let's do this done first. Let's say very fast. Let's how to do this. MgCl2. What do I do? So this means that I'm having one magnesium atom combining with what there? 2 chlorine atom. So this is how it works, please. Magnesium is separated by 12. I'm having 12 becomes this 2, 8. 1, 2, 3, 4, 5, 6, 7, 8. 2, 8, 2. Keep one at the left and one at the right. So this is now magnesium combining with chlorine atoms. 2 of it. So here's chlorine. Chlorine obviously is 17. That's 2, 8, 7. 1, 2, 8. 1, 2, 3, 4, 5, 6, 7. Perhaps. Let me move this one here. Okay. Okay, 2, 8, 7, right? So 2, 8, then 7. 1, 2, 3, 4, 5, 6, and then 7. So this chlorine 17, 2, 8, 7. Since we said we have 2 atoms of chlorine, here's 1 atom of chlorine. The second one here becomes 2, 8, 7. So 1, 2, 2, then 8. 1, 2, 3, 4, 5, 6, 7, 8. 2, 8, and then 7. This 1, 2, 3, 4, 5, 6, and 7. Observe that these terms are not stable. This one here is how many here? Okay, this one is stable, right? Yes. Observe, magnesium is stable, true of course. True. Why? In terms of the duplex configuration. This one here is not stable. Why? It's 7. It's neither octet nor duplex. This one here is not stable. Why? It's not octet. That's not it. It's not duplex. It's not what there? 2. What if this one was form a compound, right? In a case where this is formed a compound where one of the atom is stable, like this one is stable and it's duplex, and then these two are not stable, it will not form a stable compound. So what do you do here now? This becomes electrovalent. This one here transfers its electron here, comes this way. This one here transfers its electron here, comes this way. Obviously, this shell goes up. Since I transferred the electron, it goes up. What's the observation now? This one now has duplex configuration. 1, 2, 3, 4, 5, 6, 7, 8, stable. This one now has, this one actually has octet configuration 8. This one also has octet configuration 8. This one has what there? Octet configuration. Becomes a balanced compound. That's how it works. Let's look at the last one, please. Let's look at aluminium oxide, Al2O3. What does this look like? What does this look like? So I'm having 3 atoms of oxygen and 2 aluminium. Perhaps, let me leave my aluminium here. Aluminium here. Aluminium is atomic number what? 13. That's 283. So I'm having, how many things now? 283. That's the first one. 1, 2, 2, 8. 1, 2, 3, 4, 5, 6, 7, 8. 2, 8 there, 3. And now have 1, 2, and 3. Next again, another aluminium. Since it said 2 atoms of aluminium, that becomes another one there. 2, 8, 3. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. With then 3 valence electrons. 1, 2, and 3. So it's like 2 aluminum atoms. Combine this with 3 oxygen. So plus, let's put 1 oxygen there. Oxygen is atomic number 8. That gives you 2, 6. The first one there, 2, 1, 2, and then 6. 1, 2, 3, 4, perhaps 5, 6. So this is 1 oxygen. Combine this with the second oxygen. We put it this way. Plus another 2, 6 for oxygen. 1, 2. Combine this with 6. 1, 2, 3, 4, 5, and 6. Find one more oxygen. Somewhere here. Okay. Somewhere here. 2, 6. 1, 2. With 6 there. 1, 2, 3, 4, 5, 6. What's that difference is? For this one here, obviously transferring 1 electron from here will not stabilize the oxygen. So what do you transfer now? 2 instead. Transfer 1 here, goes this way. Transfer 1 from here, this way, goes this way. And this now becomes an octet configuration. It's now 8. This one here has just this one left. Transfer this one this way, comes this way. This one now is now off. So this one goes off. I'll take it off. Let's just put up now. Transfer this one here, this way, goes this way. Okay. Transfer these 2. This one comes 1 here. This one now moves here, 2 here. Alright, so obviously, having transferred this shell goes up. This shell goes up. These electrons have been moved. Have this. Okay? This shell also goes up because electrons have been transferred. It's up. So what do you observe now? For my aluminium, we're having 8 valence electrons octets. This one too, 8 valence electrons octets. This one now, 8 octets. This one here, 8 octets. This one here, 8 octets. Everything is now valence. That's the concept. Let's do the second one. Got an example, right? If it's the ones I've shown you here, like I've shown you NaCl, I've shown you like 5 compounds that undergoes ionic or electrovalent bonding. I've shown you 5 compounds. So if you can cram them, good. If you cannot cram them too, we are not doing cramming. If you cannot cram it there, you see a question on this one that asks you what kind of bonding occurs in this compound. Right? They ask you what kind of bonding occurs in, they give you a compound. What do you do now? Try to what? Draw the configuration there to give you an idea of about 2 minutes. About 2 minutes. That's covalent bonding. That's covalent bonding. Here, there is no transfer of electrons. Here, there is no transfer of electrons between the atoms. Here, there is no transfer of electrons between the atoms. Full stop. Instead, there is a sharing. Instead, there's a sharing of a pair of electrons. Instead, there is a sharing of a pair of electrons between the two reacting atoms. Instead, there is a sharing of a pair of electrons between the two reacting atoms so that both can attain stability. So that both can attain stability, in bracket, octet or duplet configuration. Such that both can attain stability, in bracket, octet or duplet configuration. There are two main types of covalent bonding. There are two main types of covalent bonding. Number one is ordinary covalent bonding. Number two is coordinate covalent bonding. Let's go to the first one very fast. First one, second one. For ordinary covalent bonding, come out. Each reacting atom, for ordinary covalent bonding, come out. Each reacting atom contributes one electron each. Each reacting atom contributes one electron each to be shared by the atoms. One electron each to be shared by the atoms involved. You can see it must not actually be one electron. It can still be more than one. So one electron or electrons to be shared by the atoms involved. Full stop. The pair of electrons shared is called shared pair. The pair of electrons shared is called this way. Called shared pair. My Igbo brother will call it shared pair. I didn't do, you know. We call it shared. They are sharing it. Shared pair. Alright, shared pair, please. Full stop. Keep paragraph, please. Examples of examples of ordinary covalent bonding. Examples of ordinary covalent bonding is found in the formation of number one, a hydrogen molecule, number two, chlorine molecule, number three, water molecule, molecule. So you have hydrogen, you have chlorine molecule, you have water molecule, you have, so these are examples of compounds where ordinary covalent bonding occurs. Let me give you an example. Every diatomic molecule undergoes ordinary covalent bonding. That's what the note. Note that every diatomic molecule, whenever you have a molecule that is diatomic, the kind of bonding formed is what? Ordinary covalent bonding. So please don't forget this. So hydrogen is diatomic, this diatomic, they are all under ordinary covalent bonding. Alright, just show you one here, so proceed. Show you one here, we'll proceed. Let's use hydrogen for instance. Let's say I have hydrogen molecule for instance. Of course, hydrogen is atomic number 1. So a hydrogen molecule has 2 hydrogen atoms. So H2 we say is equal to H plus H. H there, atomic number 1, so 1 here. Combining with H here, atomic number 1 here. So I have this. For this now, obviously, this is not octet. This is not duplet. This is not octet. This is not duplet. So they are not stable per se. How do you combine to become stable? Of course, unlike in the first one, there can be no transfer of electron. We transfer this one here, this one becomes duplet, it's stable. But this one here is dead, it's off. And that's what the agreement is there. So what happens here now? These two now combine. I'll have this one coming this way, this one are coming this way. Alright, so this one here will be sharing its one. This one here will be sharing its one. So this one that has a total of 2 valence electron. So that has 2 valence electron. It becomes stable. How did it become stable? It became stable not by transferring electrons, but by what then? By sharing electrons. So the key word in covalent bonding is actually sharing of electrons. The key word in electrovalent is what? Transfer or donation of electron. That's the concept. This is the last one. See if you can do 1 or 2 fast questions we have. Number 2 there is coordinate. Or the second part of this, let me call it I instead, is coordinate covalent bonding. Coordinate covalent bonding. Alright, coordinate covalent bonding, please. Also called dative. Also called dative covalent bonding. So it's called electrovalent or ionic. We have ordinary covalent and then coordinate covalent or what there? Dative covalent bonding. Like the also called dative covalent bonding, like the ordinary covalent bonding, there is sharing of electrons. Like the ordinary covalent bonding, there is sharing of electrons. But unlike the ordinary covalent bonding, the electrons to be shared is donated by only one of the atoms. The electron to be shared is donated by only one of the atoms involved in the bonding. Involved in the bonding. All right, let's continue, please. The electron share is called the lone pair. Electron share is called the lone pair. Too bad. It's called the lone pair. So differentiate between a shared pair and a lone pair. What is shared pair? Shared pair refers to what? Electrons shared during the ordinary covalent bonding, in which the electrons are shared between what there? The two atoms involved. While lone pair refers to what? Electrons shared during what there? Dative covalent bonding, where the electrons are what? Dominated by what? Only one of the atoms involved in the bonding process. Alright, examples of compounds that exhibit this kind of bonding includes Alright, so these are the examples of coordinates covalent bonding. Ammonium ion, ozonium ion, hexacyanoferrate 2, and hexacyanoferrate. Hexacyanoferrate 2 and hexacyanoferrate 3 ion. Right, so these are the examples of cases where we get ordinary covalent bonding. Ammonium ion, ozonium ion, hexacyanoferrate 2 and hexacyanoferrate 3 ions, that's this, and then silver diamine ion, and that's it. So usually you know if it's coordinate covalent, but when you start seeing big compounds with ions on it, because of their coordinate covalent bonding. Please, your task is this: go and draw these two. What's the task? Show that they actually show they actually coordinate covalent ion. Go and draw it. So I drew for those two. Now draw for these two and show using diagram, computer diagram, show that they actually So what am I expecting? I'm expecting that in this one I'll have 1 nitrogen and 3 hydrogen, right? And then what happens here, when I combine them, they'll be sharing. But the sharing will be done by only one there, only one. Abby? Yep. So from here, so you can even see what will happen. Nitrogen is atomic number what? Nitrogen. Atomic number what? 7. So look at it now. If it's 7, what will be the electronic configuration? Because of there, 2, 5, right? Yeah, 2, 5. So I'm having 5 there, but I'm having 4 hydrogen. So it's not like saying, look at this now. Nitrogen there. 1, 2, 3, 4, and 5. I'm doing the valence electron now. The 2 and then 5. This nitrogen. Then hydrogen, of course, 4. So to come this way here, right? What happens here? This one is it sharing? Okay. This one here with this one here with this one here with this. True. Then when you have the plus mean? As it gains or as it loses electron? An atom is possibly charged when it gains or when it loses electron. Which of them? When it loses. What happens now? Now lose. How many is it losing here? Now lose this one. Now becomes 2, 2, 2, 2, 8. So what? Just like the next one. Go and work on this. Go and check out. Sorry, that's what I do. Let's complete with this thing. Let's complete with this. So I'll just drop past with you. You go work on them. Other types of intermolecular forces include other types of intermolecular forces include like apart from the electrovalent or ionic and the covalent, you still have dipole-dipole interaction, you still have van der Waals forces, you still have hydrogen bonding, right? These three here are actually weak forces, right? Not from the actually weak forces. Example in what do you call it? Naphthalene crystals. You have van der Waals there, naphthalene crystals. Same thing with what do you call it? Substance that's sublime, right? Just like you had your camphor, right? You have camphor, you get camphor, a new camphor, keep it in the bag. What happens there? Becomes smaller with time. What's happening there? It's actually losing part of itself. Why? Because the kind of force there is not strong enough. It's not strong enough to hold down the particles. So hence, once air blows through, what happens there now? Start what there, giving out each of these ones, these particles becoming what there, smaller and smaller. Why? Because the force of attraction between the naphthalene or the camphor quote is what weak van der Waals forces. Same thing happens with what do you call it? Spirit, right? You don't expose spirit to air, true? To just dry off. Why? The force that holds its molecule is not strong enough. It's just one of these big forces, and hence it sublimes. So that there is the concept. So call it a day, right? So should we revise past question? Call it a day. Yeah? Just one. It's also closed by 5 p.m. Alright, let's try this. Let's try this question from 2012, question 50. 2012 question 50 says the type of bonding in the geodis Alright, is there your options? That's like for this year. Say type of bonding in this ion is dash A, B, C, D. Which is the answer? Obviously A. Alright, so that's how it works. So go look for others. Especially please, I would advise you read up on this one. Go and read up on this one. Look for I can't read documents. Look for this one. Right. But that is I said but that is just saying higher ions. Right. Please read up for, I know they like asking about hydrogen bond and then metallic. One for this one too, metallic. Right. Alright. See when click.